I want to talk about even more things to be looking for when you are doing code reviews on a pull request. So I did a first list of this a couple days ago. I have a video out you can go check out. This is going to be expanding upon that list. So let's get right into it. Too much copying data, memory leaks, magic numbers or magic strings, confusing logic with no comments, change of existing functionality, undocumented changes, unnecessary features, and writing something that already exists. So I'm going to break each of these down and we'll talk about it. The first one, too much copying data. If you have a variable and you assign that variable to some amount of data, whether it's a very big list or an array or whatever it is, if you routinely are either cloning that array, you're copying the variable, you're reassigning it to other variables, and you continually are moving all that data around, and you're loading that data consistently into memory each time, that's something that you can potentially refactor if you can. So when you are looking at it and you're reviewing code, just be mindful of how many times you're creating variables, and do all these variables need to be created, or can we add filters, or can we add some logic to the list without having to explicitly reassign that list to another variable, act on it, and then do that again. So it's easy to write code. It's easy to write code that you just make a variable assigned to the list and then you do that. But sometimes it's not that memory efficient to do that, especially if you are dealing with larger data. So when you are looking at code, just be mindful of how many times is that data being loaded into memory. The next one, which is on a similar tune, is be on the lookout for memory leaks. Memory leaks can happen for a number of reasons. If resources are not released for garbage collection in the context of C# and .NET, that those resources, those pointers, will persist in memory, and over time that can grow. And we looked at on this channel one way to identify memory leaks. .NET has some built-in tools you can do that. You can look at the IDE diagnostic tools you're using to visually see how much memory is being used. And .NET is a concept of the heap and the stack. And .NET C#. Memory leaks are challenging because sometimes they don't manifest themselves early on, and sometimes you don't see them until at a later time in the application's life. But this is something to be mindful of, especially if you are dealing with larger data sets and you are having to load them into memory consistently. You want to make sure that that is being released upon basically the end of scope of the executed code. And one easy way to identify that this is not happening is if there is, for some reason, a global variable defined at the top of your class, and that is then being set to the data, whether it's a list or whatever it is, and the data is large, but then you don't nullify that global variable, that will persist in memory, therefore creating this basically memory leak, because it's going to be sitting there. And if you're adding to that global variable elsewhere, then you're creating this basically reference that never gets that just stays there. So garbage collection is not going to pick that up because it still has active pointers to put spots in memory, and so therefore it'll just grow and grow. And that's one example of a memory leak. So you want to just make sure that you're reassigning things to null. But memory leaks can happen in other ways too, and it's just something to be mindful of. And that's why it's so important to have a very functional development set up so that you can reproduce these things, especially if you're working with complicated code that somebody else put up. You can potentially pull that branch down, run it, and then see, just be on the lookout for a potential memory leak or a spike in memory. And especially if you have like a suspicion that that might be the case, then it's worthwhile to discover that, because the last thing you want to have happen is an overflow and then a system crash, and then you have to go back and revert the pull request, and then it can be a whole mess. So if you have a suspicion, don't be afraid to ask about it, and don't be afraid to try it out yourself, or have the person who's making the pull request show you that there's not There's not going to be a spike or a memory leak. The next one are magic numbers or magic strings. Basically, all this is jargon to describe when there is a number that's used and it feels odd. It's an oddly specific number. So it would be as if I was saying, if my camera's cost is greater than $100, then do this. Or if my camera has, only has two lenses, then I have to do this. It's these numbers that make sense to the writer of the code, but don't inherently make sense to the reader of the code. And the same thing for strings. If you have a string being checked that it's not, hey, and a reader comes, well, why does it matter if the string is hey or not? So these things that make sense to the writer need to also make sense to the reader. So in order to justify the use of a magic number or magic string, it could be better you can either make that a constant and name the constant something very specific, like, cameras with two lenses go on sale, or, cameras over 100 need to do this. Something that that allows the reader to make sense of the number or the string. And you can, I would suggest doing the constant over the comment, just because well, not really. The comments work too. I don't know. I would probably do a constant, or a string with a variable or property with like a very specific name. But a comment could work too. I mean, something, as long as something is associated with that number or that obscure use of logic, then I think you're good. But you got to explain that a little bit, because code has to make sense to everybody, not just the writer of it. The next one are similar, but it's confusing logic, comments. So if you have really confusing logic in there to say, like, if my camera and my wall are present in the same room, then I'm reading a book. Just something that doesn't inherently make sense to the outside. And I think that you can kind of pick up on like what is confusing logic and what is not, especially if you're dealing with a lot of like inverted conditions. If you're doing a lot of not conditions, if you have a lot of ifs and you have a lot of is not this, just all these things that you want to make sure that you're writing that in as plain text, as clear text as possible, in a way where you can feel confident that a year down the road you can go back and make sense of it. And what I personally find easier to read, because I like to write code in as plain English as possible, if you can move that out into a function or a method, name the method very well. And it doesn't matter how long that method is, or how long the name of the method is. Don't try to be terse with your method names. Be as explicit and explain what it does in as clear English as possible, because it's really easy to read a sentence, but it's very hard to read a sentence that's been like condensed into the use of acronyms and shorthand of words and everything. It doesn't matter. Just name it something that is clear. So if I want to, talk about why I'm reading when my camera and my I have a wall, then I just name a function like, Stephen is reading. Is Stephen reading when camera and wall are present? It's something to name what is happening, and to eliminate any kind of like ambiguity as to like, should this be happening? It's very hard. That's where the difficulty, I think, in development comes into, because naming things is often described as the hardest thing to do in computer science or software development. And naming methods is very difficult. And naming methods, for whatever reason, some people try to name methods very short. I try to name methods very long because I try to be as descriptive as possible, because I want to make sense, especially down the road. The next one is going to be change of existing functionality. If there's ever code that is, changing what's already there, that should raise some red flags as to should this be changed, And also, does it need to be wrapped behind some kind of feature flag to make sure that logic if the new logic that we're adding breaks something, can we easily revert back to what was already there? And I've talked about strategies to do this on the channel. I've talked about research papers that you can read years ago. You can do this through data structures. You can do this with database tables. You can do this with so many different things. But it should spark a question to say, okay, what's the existing functionality that's there? Should we be changing this? And if we do change it, what happens if it breaks? So just be thinking about that, and especially if you have to go, if you have to change unit tests that are already there, that should warrant a second look or a second opinion about the pull request. So the next one is going to be documentation. Basically, stick to whatever is written up for your task. You don't want to deviate beyond what's written up for your task, because then it becomes a little bit harder to figure out the root cause if there is a problem that arises. So you want to make sure you do the minimal code possible to accomplish the task, because if you do see something that really warrants a change that's outside of the scope of whatever task you're working on, the ticket, you should write up another one but complete the one that you're working on now, and then move on to the next one. So that way you separate out, the work, but if something does break, you can point it back to one or the other. What happens is if you try to fit too much code into a pull request under the same task, then it becomes harder to pinpoint what the problem was if there was a problem that was introduced. And then you have to roll back a lot more code, and it becomes harder to kind of unwind that. And it also becomes a lot harder if you have to resolve any merge conflicts if somebody else is working in the same spot and they have a branch they're trying to merge into main, it becomes harder to do that. So you want to make sure that your code changes are as minimal as possible, and if you do have to make additional ones, those should be external to the one you're working on now. The next one is going to be unnecessary features. It's easy for us to look at code and always think of like a million things we want to change and add additions to whatever it is we're working on to make it better. But you want to minimize how often you're doing that, because it's easy to kind of get lost and just start adding things and making it better. But that's all fine and good. But when you release it and there is a problem, it just becomes so much more to roll back and unwind. And so despite, the fact that we may be tempted to add in features that are good or features that have been requested, you want to make sure, again, going back to kind of the last point, you want to stick to your current task and you want to keep it as minimal as possible. And if you do see features, every feature should be its own individual task. And that just, again, to keep it organized, but also to minimize the impact of the code that you're releasing. The last and final one for this list of pull request review guidelines is you want to check for or ask the question, are we writing something that already exists? And you always you can never get around rewriting something sometimes, right? You always have to, at some point you're going to have to write code. But if it's a sizable feature or a sizable task that has already been implemented, either in a respectable library or the framework that you're working in, like .NET, you should really consider using what's already there at your disposal. You don't want to fall into the trap of feeling like you have to rewrite everything yourself. You really should consider what the community uses and just ask yourself, does it make sense for us to spend all the time to write it ourselves, or should we use something that's has already been implemented and it's very well supported, and you save on the time, because time is money, and time is something that needs to be heavily weighed. You're right, because there's costs and benefits to whatever you do, and development time is quite expensive. And so if something, especially something technically difficult, has already been done, it warrants a second look, or at least a second opinion to a broader audience, to ask, hey, I have this task. and I see it's already been implemented here. Can I use what's already been implemented in this, open source framework or in the library or whatever it is? Can I use this? And I think asking that question can save a lot of maintenance costs in the future. But there's also downsides to that, right? You lose the ownership of whatever the thing you're implementing, and you become a little bit more dependent on updating that, right? You have to update the dependencies. So there's trade offs to it, but just ask the question doesn't make sense. And I think that that'll help guide the conversation into a better spot. So thank you all for this, watching this list, and I'll see you in the next one.